Okay. Good morning, everyone. It's 11 a.m., so let's get started with our webinar right on schedule. Thank you for joining us today and welcome to the first content webinar of the year. Today, we will explore how open data and LivingAtlas can work for you. This webinar will be brought to you by the content team. I'm Carolina, a GIS graduate at Eagle based in Auckland, and leading our content team is Barwin, who is also a technical solutions consultant, and we're also joined by Joshua, Franklin, and Mia. We have a variety of exciting topics to cover today. First on our agenda is open data. We will explore various data portals and resources available to you. We will also touch on how to integrate web feature services into ArcGIS, and we will look at publicly available imagery that you can utilize in your work. Next, we will jump into the LivingAtlas, which will also mention about the content hub we have released. Then we will introduce you what's new and show you how to make the most of this valuable resource. Moving on, we will discuss how you can contribute to open data and to the LivingAtlas by nominating your own layers. This is a fantastic way to share your work with the broader community and enhance the collective resource pool. And finally, we will wrap up with some additional resources to further support your work. We will also have a Q&A session where you can ask any questions you may have about the topics we have covered today. For Q&A, you can find the question panel on the right-hand side of your screen. Feel free to ask questions at any time, and we will address them at the end of the webinar. Now I'm going to pass it over to Barwin to talk about our first topic, open data.
Yeah, thank you, Carol. Yeah, so let's talk about open data, because New Zealand has access to a lot of open data, and that comes from a wide variety of organizations. Probably some comes from the organizations that you work for as well. And here we see just a small selection of all of the data portals that are available that provide geospatial data. And having all this data available is great, and all these different portals can make finding and using the data a bit of a challenge, even more so if you're not a geospatial professional. And it would be great if more of the data is managed, that is managed by council would be brought into, I don't know, some sort of a national layer with the same schema. And maybe that's something that we can work on as a GIS community together. But also those different portals, they have different ways that you can download or connect to the data. Some also require you to sign up before you can access the data, or have some restrictions on the amount of data you can download each time. We also see that more and more open data is published to ArcGIS Online or registered in ArcGIS Online, so it can be easily found and used. And these layers can also be added to open data sites in ArcGIS Hub, for example. And some of those layers are also available in LivingAtlas to make them even easier to find in ArcGIS. So one example of them is the layers from LIMS, for example, that you can find in LivingAtlas. And not all layers can be added as LivingAtlas layers, unfortunately, because some of the organizations that publish them have, even though the data is public, some restrictive terms of use that stops it from making them available in LivingAtlas. And although that can make it a little bit harder to use those layers, in ArcGIS there are many ways to either connect to the open data, or to set up ETL processes and convert the data to, for example, feature layers and schedule update on those layers as well. And next, I want to have a look at some of those options, and for that I'll pass it on to Josh.
Thanks, Barwin. So one example of open data that can be brought into ArcGIS Web Feature Services, or WFS for short. So firstly, we'll explore how Web Feature Services can be brought directly into ArcGIS Pro. So you can navigate to your Insert tab on ArcGIS Pro, select and then Server, and then New WFS Server. And then from here, you can enter the URL to your WFS and add custom parameters, such as max features, and secure features, filters. Once you've entered your parameters and selected OK, you can open the servers dropdown in the catalog pane and add your web feature services from there. LINs have detailed documentation of best practices for working with web feature services in Pro, and a link is provided on the screen in the corner there. And you can also apply spatial filters if you'd like to limit the extent of your data that you're bringing in. And once again, further documentation can be found on the LINs website. So web feature services can also be brought in through the ArcGIS Online Map Viewer and Enterprise Portal. If you would like to directly add your web feature services into your map, then go to the toolbar on the side and select Add Layer from URL. And then in the Map Viewer sidebar, add link to web feature service with the LINs data service as long as you have your URL with your API key. And then you can also add custom parameters such as the SQL filter, as I mentioned in the previous slide, which allows you to filter records from within fields. But if you want to create an item directly in your portal, as seen on the right, this can also be done from the content page by selecting New Item, then selecting URL, and then copy and pasting the web feature service URL. And then ArcGIS Online will automatically detect this as a web feature service. And then once again, you can fill out the parameters as required. So the methods above provide easy access to web feature layers over a server. However, local ArcGIS feature classes contain further capability. And to get this full functionality of these feature classes, such as offline capability and full access to editing and geoprocessing tools, you can use the tool WFS to feature class. And this will export the web feature class, web feature service to a local database as an ArcGIS feature class. For parameters, again, in the first parameter, you can add the URL of the WFS. And then once you've added this, a list of all feature types available from this list will display in the dropdown for the select feature type to extract parameter. And by default, all features from the web feature source will be added. And that's where you can specify them in that parameter there. And then finally, you can specify the name and location of your feature class. And then you can note with this tool that you don't need to use the add WFS server connections. You can just add the URL directly into this parameter. And with a new offering in the ArcGIS suite, data pipelines, this provides further capability for bringing in data from various sources, which Mia will demo now.
Thanks, Josh. Data Pipelines is a new data import application that allows you to connect to external data sources and bring them into ArcGIS Online. ArcGIS Data Pipelines enables you to connect to and read vector or tabular data from a variety of data stores that's accessible through credit usage. You can then transform the data and write it to a feature layer in ArcGIS Online with the option to automate and schedule your workflows, allowing them to be run on regular intervals. You'll notice that Data Pipelines is a no-code graphic user interface. On the side panel here, you can see it's made up of 3 elements: inputs, tools, and outputs. To use files uploaded to ArcGIS Online, select where you want the file to come from. Here you can browse existing through your data already in your organization. To access data in cloud storage such as Amazon S3 buckets, you'll need to add a new data store connection. Here you'll need an access key and the secret key and the bucket name. Then you'll click Next and add in that data source, the name. In this data pipeline, I've added in a public URL to show that WFS layer. I've copy and pasted in that URL and selected the right file format. Here it's CSV. What's great about data pipelines is you can now preview that data. This is going to take a few seconds because there are over 8,000 features in this layer, and it covers all of New Zealand. So once it loads in, you'll be able to see that data. But what's great about data pipelines is you don't just have to bring in that whole layer. You can use all the tools here to edit it. You've got the clean tools that you can filter your data, construct to calculate fields and create geometries, formats to change the projection, update fields, and integrate to join and relate to different tables. In this pipeline, you can see I've used the Create Geometry tool to create a polygon feature class. Again, this is 8,000 features, so we're not going to preview it, but here we've filtered by an extent. You can filter by attributes as well, and here you can filter by defining your own extent or using the extent of another data set. In this case, I've used the Hawke's Bay region, so we only have the soils there. We can preview in the map preview here, and again, taking a few seconds to load. But you can see now that that geometry is all loaded in. Now, what you'll need to do is configure your output tool. Here, we're creating a new feature layer called Hawke's Bay Soils, and then you'll run it to create that feature layer in ArcGIS Online. What's also great is you can now schedule these pipelines to run by clicking Create Task. Here, you can decide whether when your data is updated, you can repeat it either every hour, day, week, or month, really easily by selecting that start date and saving. Here, you'll need to configure the output setting again to either replace the data or add and update it every time it loads. If a picture interests, we've also got some great extra resources, some story maps to help you get started with your data pipelines and to use all those different inputs. Thank you.
Yeah, thanks, Mia. Yeah, a great tool to bring in some extra data, some of that open data that may not be directly available in ArcGIS. All right, the next topic that we want to talk about is the public available imagery. And again, New Zealand is really in a league of its own when it comes to the availability of this high resolution imagery. And that goes both for the aerial imagery as for the elevation data. And what we can see by the usage of the derived products that we create, that they are very valuable to many users and organizations. So one of these derived products is our NZ imagery base map. And what we do with this public imagery is that we create a base map that shows the most recent or highest resolution imagery for each location in New Zealand as a base map in NZTM. And we do this by managing all of the imagery, mosaicing, and casing it as a base map. So you can all use this as one of the base maps available for New Zealand. And every time that new imagery is available, we'll update it to make sure that it gets added. And just in the last year, I think we've added over 40 new datasets to this base map. So it keeps us busy. The great thing about this base map is that it has the offline capability. So it allows you to create an offline area, download that, for example, for apps that need to be disconnected. For example, ArcGIS field maps, if you take it out in the field where there's no reception. And to make navigating this base map easier, we also created a reference layer. So this adds roads and labels to the map without interfering too much with the imagery, as you can see here. So another source of that public available imagery is the elevation data that has come available in the last few years and is still being collected. And as you can see here in red is good. The areas are all the areas that currently have 1 meter resolution DEMs and DSMs available. So if you need access to this data, you can download this from the LINS data service for the DEMs or the DSMs. If you need access to the source LiDAR, you can download that from opentopography.org. And to make using this data easier, you can also find a variety of layers in LivingAtlas that use the data that is being produced by all the councils and made available by LINS. So a few of those layers are, for example, the Esri terrain layer. So Esri manages a dynamic image surface with the best available elevation data across the world. It can be used for analysis, but it can also allow you to create different visualizations dynamically. So you can visualize things like slope or contours or shaded reliefs on that surface without having to download the data. What we do as well is we create hill shades from both the DEM and the DSMs and make that available to complement our NZTM base maps. And also Esri creates those hill shade layers in the Web Mercator projection. And then we also create a nationwide elevation layer in NZTM that can be used in 3D scenes and gives you that 3D view of the world. And again, this data is also being used by Esri for their elevation layer in Web Mercator. So Mia created a couple of story maps that show you how you can access the data, whether that is using it, downloading it from LINS and then doing some analysis on it, or actually using the Esri dynamic imagery layer and use that to visualize the data in different ways. So it's a great source that you can find in the content hub that we'll talk about a little bit later. So most of the imagery that you can find shows the latest or highest resolution imagery. It's case for fast performance. However, there are use cases where you need access to, what is it, the actual TIFFs, the actual source imagery, for example, to run analysis or deep learning workflows, or you need access to some other imagery that is not shown in the base map, for example, to do change detection or to understand what a location used to look like. And before, you would have to go to the LINS data service to find and download the data and manage the data locally. But last year, it has become a lot easier to do that. So LINS has made all of their aerial imagery available in a public S3 bucket. So that's an Amazon Web Services location. And in that bucket, you can also find some of the older imagery. Some of the imagery is like really old, as in before I was born. So that is black and white imagery. And ArcGIS fully supports connecting to cloud stores like AWS S3 buckets. So you can now directly connect to and manage the imagery for a variety of use cases. And to support that, we've created a whole story map collection with how-to guides on how to access, manage, and use the imagery in ArcGIS without having to download that data. And Josh, who worked on these story maps, he will give you now a quick highlight tour of some of those workflows where you can find the detailed descriptions in the actual story map. So over to you, Josh.
Thanks, David. So the first step in accessing the LINS S3 bucket is to create a cloud storage connection. So this can be done by navigating to the Insert tab, selecting Connections, then hovering over Cloud Store, and then selecting New Cloud Storage Connection. So here you can fill out the key parameters, such as Amazon as a service provider, then NZ Imagery as the bucket name, and also other parameters such as the region and other parameters down here. So this then creates a cloud connection file, and this is where we can see all the folders containing imagery from various regions around the country, as we can see here. And then once you've made the connection to the S3 bucket, you can leverage the imagery by adding it to a Mosaic dataset. And this Mosaic provides a centralized location to store all the cloud imagery that you're bringing through the S3 bucket. So here is where you can bring in the S3 folders from selecting this button in the Add System Mosaic Dataset tool. Sorry, it doesn't look like that's showing. So basically, when you open this tool, you can see the interface and you can select cloud stores from the interface, and then you can select the folder that you need and click OK. Just making sure you've got folder selected on here. So for the initial source Mosaic dataset I've got here, I've got 5 centimeter imagery of Napier flown in 2022. So the main difference between this workflow, where we source the rasters directly from the S3 bucket, and downloading the imagery, is that the Mosaic dataset references and renders the data we're seeing here, the imagery tiles we're seeing here, through the cloud, rather than on your local machine, local drive, which would take up extra storage on your machine. And a great use case for this is to create for this imagery is to create base maps for your own organization. So you may want to add multiple mosaic data sets with other folders sourced from the S3 bucket, as I was shown before. So you may want to have a mosaic data set that shows urban imagery, which you want to complement your rural data set for your map. This can be done by creating a source mosaic data set for each of the individual mosaic data sets, source mosaic data sets you need, as you can see here, and then creating a new derived mosaic data set. And this is where you can add all your individual source mosaics for your base map. And the second story map in our collection shows how to do this in more detail. You can also configure the display order of your source mosaics within the derived mosaic. So for example, in the properties here, you can set your urban datasets to display above the rural by setting your display order by attribute, as you can see here, the defaults pane in the properties. And next steps here, you can choose either to cache the base maps using the workflow displayed in our 4 story map in our story map collection, or you have some options to upload it as an image service to your enterprise portal. And here we'll mention 2 ways the latter can be done. So from here, you can right-click the mosaic dataset and select share, and then share as webplay. And this will share the mosaic as a dynamic imagery layer to your enterprise portal, provided you're on an enterprise. And then another way is that the second method is detailed here in the second story map in our collection. And this is for if you want to create an image service straight through the portal interface, rather than doing it from ArcGIS Pro and then sharing it there. So firstly, you can create a data store item. And you can then create an imagery layer where you source it from the S3 bucket, as you can see from here, using the image collection configuration. You can then select the data you need from the S3 bucket to add to your image service. We've created an image service with all of our imagery there as a test. And with a new ArcGIS Online capability, you can view the imagery within our map extent through the Image Collection Explorer. So from here, we can display the fields we're interested in. So for example, we may want the category, whether it's primary or overviews. And we may want the flown from date. And if we add these here, we can display them here. We can then preview the image that we'd like. Load. There we go. So you've got a preview of the image, and you've also got some metadata here down below. We can then zoom to its extent, and then add the layer to the data set, as you can see here. Now I'll pass it back to Balavain to talk more about WMTS layers.
Yeah, thank you. So that's a really powerful way to access the imagery that is available up there, not just the latest and greatest imagery that is there, but also looking back in the future and maybe getting some of that old imagery just to see what an area looked like. So great demo, and again, those story maps, they outline each step in the workflow to get you guys started with this. So another way to look at some of that imagery that is available is highlighted in another story map in this collection, and is to add WMTS layers to ArcGIS. So Lins makes these all of these data sets available as WMTS. And although there are some limitations, like you can't take them offline, it can be a real easy way to show some of the older imagery in your project. So again, look at the story maps that we'll put a link to later in this webinar to find the how-to guides to see how you can access these layers. So sort of related to this topic is GeoAI, because imagery and elevation data usually holds a lot of information and data that can be used if you extract it from it. So you can think about finding specific objects like solar panels, poles, or building outlines from imagery, or classifying vegetation in LiDAR to do some vegetation encroachment analysis, for example. And deep learning is a great tool for that. And ArcGIS provides tools to do the whole deep learning workflow. So that goes from labeling and training to the inferencing, as in actually finding those objects. And especially that first part, that is very time consuming, as in to label and train your data. It's time and resource heavy. And that is why Esri and Eagle both work on making deep learning packages available. So you don't have to do the labeling and the training. You just need access to imagery, which we just shown is relatively easy now. And then you can run deep learning over those imagery data sets. So please check them out in the LivingAtlas. And as you may expect, we also created a couple of how-to guides on how to use the specific deep learning packages for the New Zealand specific ones. And for the Esri ones, there's how-to guides available as well. One that I want to highlight is in the top right corner, and that is the text SAM. So basically, this is where Esri combined the segment anything model from Meta and combined that with a text prompt, which is based off another model. So segment anything can segment anything in your image, but it doesn't really know what type of objects they are. But by combining this, you can now ask the model to find, in this case, airplanes or buildings or trees. And it will use the segment anything model to segment it, and then use the other model to find just the trees or the buildings in your segmented data. So that's a really powerful one. And with that, to show more about what is available in LivingAtlas, I'll pass it on to you, Carol.
Thank you, Baldwin. Yep. In addition to the open data portals freely available to you that Baldwin just mentioned in the beginning, as Esri customers, you have access to the LivingAtlas as well, the foremost collection of geographic data in the world. Being an Esri product, LivingAtlas seamlessly integrates into ArcGIS, meaning you can easily add and use the layers from LivingAtlas to create maps, scenes, apps, or even to perform analysis. Using LivingAtlas also ensures the integrity of your work, as all layers need to undergo a quality checking process to earn that authoritative tick. They are also ready to use, saving you time and resources since you don't need to download, publish, or maintain them by yourself. And much of the content themselves are contributed by the wider GIS community. LivingAtlas features a variety of world datasets, including New Zealand-specific datasets and deep learning models. To learn more about New Zealand-specific LivingAtlas content, we have published another valuable data repository, the Content Hub site. One of the key functionalities of ArcGIS Hub is its ability to share data and content. Over the years, we have added many layers to the LivingAtlas, and leveraging its core features, we have centralized all this data in our Content Hub. The main reason for creating this hub is to promote New Zealand-specific content in LivingAtlas. And as existing ArcGIS users, again, you have access to all these valuable content, and you can make use of them. Additionally, we have incorporated how-to guides that we have created over the years to help you maximize the potential of the available content. With all these layers available in the LivingAtlas, it is important to know how to find them, and there are several ways to do that. Starting from the LivingAtlas or livingatlas.com. This allows you to access the collection of layers that can be integrated into your maps, and you can search them by keyword, category, or location. Next, the ArcGIS Online content page. To access this, open your ArcGIS Online account and navigate to the content page. Here, you can search for the LivingAtlas layer again and view its item details. Next, when you're in the map viewer, when adding the layer, you could expand the drop-down list and click LivingAtlas. Last but not least, ArcGIS Pro. You could import your LivingAtlas layers through a portal in the catalog pane. One of the most used types of LivingAtlas content are base maps. Base maps are foundational for your maps as they provide reference and context. To choose a base map in the map viewer, you can select it from the gallery of your organization, which is usually a pre-configured collection of the LivingAtlas. Or you can use a base map that is not in the gallery yet by browsing the layer from the LivingAtlas and add it manually onto your map. Eagle provides a variety of base maps in NZTM projection. These base maps are created with the best available data for New Zealand from authoritative sources and OpenStreetMap routing data. We have a combination of vector, raster, and hybrid base maps, and they get updated regularly. For example, vector base maps are updated monthly. Working with elevation surfaces is fundamental, as they define the height values across the extent of your map or scene. A scene always includes at least one elevation surface layer representing the ground. While you cannot remove the ground surface, you can replace its elevation source layer. So for example, in Scene Viewer and ArcGIS Pro, you can search for New Zealand elevation layer from LivingAtlas and add it to your scene as an elevation source. Additionally, you can also pick a default elevation layer for your scenes in ArcGIS Pro or ArcGIS Enterprise. For example, in ArcGIS Pro, you can choose to have no elevation source or your organization's default elevation or a specific one that you prefer. So just go to the Maps and Scenes section in the Options page in ArcGIS Pro to set it up. From there, you can find your preferred elevation source from LivingAtlas, such as New Zealand elevation. On the other hand, in ArcGIS Enterprise, you can add an elevation service to your portal by putting its URL in the Utility Services configuration page. The exciting thing is that the ground elevation layer will automatically change depending on the base map you choose. So if you select a World Mercator base map, you will see the global terrain. But if you pick the NZTM base map, it will switch to the New Zealand elevation layer. By choosing a default elevation source, you can make sure your scenes always use the elevation data you prefer. You can also transform LivingAtlas layers into your own highlight layers. For instance, here we have an example where OSM shops layer have been filtered, analyzed, and visualized using tools available in the map viewer to understand the impact of supermarkets based on the population values. So I use various tools such as generate travel area and enrich layer with Stats New Zealand census data to provide population figures within those travel areas. Finally, you could also create an instant app to offer a more interactive experience of the map and data that you have customized. Therefore, by leveraging both LivingAtlas layers and ArcGIS tools available, you can maximize their value by tailoring the data to meet your specific needs. Now let's have a look at what's new in content, and I'm back to Josh to talk about GNS shaking layers.
Thanks, Carol. So GNS have introduced their shaking layers into ArcGIS Online and the LivingAtlas, and these provide information on earthquake events that have happened within the last 30 days. So each available layer displays earthquake events from the last 30 days, and these layers are available within 10 to 20 minutes of an earthquake for specific events. So users can bring in their earthquake layers to complement their own data. And when you're adding the shaking layers to your map, you can filter the events by various fields such as quake ID, magnitude, depth, and time, and more. And you can make use of GNS's pre-configured symbology straight from the LivingAtlas layer. We've also recently released a new contours layer that is currently available in beta. So it uses the 1 meter elevation data where it's available currently to create 10 meter interval contours of New Zealand. And currently we have released 2 styles, one to suit our light color base maps, as you can see on the right image here, and another to complement our darker base maps, such as our imagery base map, which you can see in the bottom left. And you aren't just limited to the styles we've created here. You can also customize your own. And you can do this using the vector tile style editor. So this tool allows you to adjust, say, the colors, the transparency, and which type of intervals you'd like to display for the contour layer. As we said earlier, this layer is still in beta, so we're looking for the best ways to process this data still. We're still doing constant R&D on this. And we also don't recommend using it in your production environments just yet. So as of the ArcGIS Maps SDK for JavaScript 4, you can add multiple vector tile sources into one layer. So the vector tile styles from our contour lines layer, as we just mentioned, and the NZ topographic from the leaf base map, these items were combined into a single vector tile to create our multi-source vector tile layer, as you can see in the item in the bottom left. You can also adjust the drawing and display order of these vector tile sources yourself. So for example, we've moved buildings and roads above the contour lines in the multi-source styles JSON file. Therefore, contours will be drawn underneath these features in the map. We've provided a comparison in the images above. So the image in the top, you can see that the contours are drawn underneath the buildings there, compared to the bottom layer, where the contours draw over everything else, if they're just draped on top. And then the link in the corner of your screen will send you to a blog that provides further information and context on how these multi-source layers work. And we'll also have a story map coming out soon with further information and description on these contours and multi-source layers. And as we said earlier, we're always looking for feedback on these layers. So feel free to email us with any questions or suggestions you may have. And now I'll pass it to Carol to talk about geo-enrichment.
Okay, another new content is geo-enrichment. Last October, the ArcGIS Online update included significant improvements to the geo-enrichment service and the underlying content for New Zealand. The addition of 2018 Stats New Zealand data to Esri's global data portfolio really enhances the available variables for New Zealand, offering a more comprehensive demographic dataset for analysis. This now allows you to gain valuable insights by combining polygon layers with demographic data across various ArcGIS products like ArcGIS Online, ArcGIS Pro, Enterprise, Business Analyst, and even ArcGIS for Microsoft 365. It is also important to note that the geo-enrichment tool summarizes variables differently from other tools. For example, the Summarize Within tool calculates variables based on the existing polygons, providing a more straightforward count or summary within those polygons. In contrast, the geo-enrichment tool uses more advanced techniques. It analyzes each polygon in relation to a point dataset, meaning it will apply detailed aggregation and apportionment methods to redistribute variables accurately to the input polygons. More information about geo-enrichment and its algorithm is available in the story maps we have published. Now I'm gonna jump into my demo about geo-enrichment. One way to use geo-enrichment is through a suitability analysis workflow in the Business Analyst web app. Suitability analysis allows you to automatically rank and score potential business locations based on multiple weighted criteria, helping you identify the most ideal site for a new location. When adding a new criteria, you can utilize the data browser, which offers Stats New Zealand census data. For instance, here I have included various demographic variables such as working age population, preferred education level, etc. After adding the criteria and adjusting the weights and the scoring method, the app will provide you a list of the top scoring sites based on your chosen criteria. And when you hover over a site, it will display the enrichment values. Additionally, one of the most accessible ways to use geo-enrichment is by using the Enrich Layer tool in the ArcGIS Online or ArcGIS Pro. This tool allows you to enrich a specific polygon layer with additional data. And when adding variables, again, you can access the data browser, which includes Stats New Zealand census datasets. This tool will essentially generate a new output feature class, which is a copy of the input with additional census attributes added. For example, here we have enriched the drive time buffers with Stats New Zealand census data. The first batch of 2023 census data has just been released as well on the new Stats New Zealand Hub, offering open data for you and customizable layers for your needs. In the future, when all 2023 census data layers become available, we are planning to integrate them into the geo-enrichment service as well. Now I'm going to pass over to Josh again to talk about how to use ArcGIS to publish open data.
Thanks, Carol. ArcGIS is a great platform for publishing your open data. So when you publish your layers to ArcGIS Online, you can either just use them in your own products and maps, or you can use these very same layers to make them available to the public. So once a layer is published, it can be added to open data sites and portals such as data.government.new Zealand. You can set your item to be exported to various formats such as CSV, GeoJSON, shapefiles, and geodatabases. Whether you're publishing your data internally within your organization or externally or publicly, it's important that your item and data are easy to interpret by other users. And this starts with good item details that describes what the data is showing, as well as your field names and aliases, pop-ups that display important information, and good symbology. In ArcGIS Online, you can also give your item an authoritative badge. And you can see it in the green authoritative badge in that screenshot there. And by default, this badge will only be visible to your members of your own organization. However, you can work with us to get your organization verified. And this will mean that this authoritative badge will also be visible to the public on your public layers, as well as your open data items. The setting also adds the organization name to your item details. So for your organization's authoritative layers to reach a broader audience and be easy to find for your users, we highly recommend you look to nominate them to the LivingAtlas. So when your layers are incorporated, there is less chance of unnecessary layers uploaded through numerous sources, so you have a centralized location. And as Carol mentioned earlier, once the content has been nominated, it can be accessed directly from ArcGIS Online and ArcGIS Pro. So it's much easier and quicker and easier for the users to leverage. And there's potential for your data to be used in users' public story maps and web apps, and this further extends the reach of your layers. And when enabled, the data can be exported to other formats for users to use for different systems. The LivingAtlas is just a catalogue of authoritative data, so there's no extra effort required to nominate it. And also users will know whether the layers they are using are authoritative, active, and up-to-date. So alongside Esri and Eagle's published content, we see more organizations contributing their data to make it more discoverable, such as Te Puni Kōkiri here, KiwiRail, LINZ, and Niwa. And a very recent example of this down the bottom here, as we explained earlier, are the shaking layers from GNS. Your organization can also be in this list. Before you hit the nominate button, your item is scored based on how complete your metadata is. This score is it provides below tips that can help you improve the score, help to make sure that you have good metadata for your item. Your item needs a score of 80 out of 100 before it can be nominated to the LivingAtlas. But the closer your score is to 100, the better it is. And adding these item details is good practice for all your layers as well, regardless if they're published on the LivingAtlas. We'd also recommend to take time in creating great thumbnails for your items. And this provides visual aid for the user so they can get a glimpse of what your layer is about. And when you nominate these, Eagle will review each of the items, and then we'll contact you if we have any other further questions or queries. And make sure to maintain your items by keeping them up to date when necessary. And this means you'll have more visibility for your layers. And we've also created a story map that explains the process of nominating your your layers to the LivingAtlas in more detail.
Okay, thank you for staying with us through this webinar. As we conclude, I want to highlight that the content team at Eagle is always keen to hear your feedback. We welcome any new ideas or layers you'd like to see in the LivingAtlas, and we look forward to collaborating with you and assisting with your nominations. I would also like to share some valuable resources that we highly recommend for working with open data and the LivingAtlas. So first, we recommend the ArcGIS blogs and ArcGIS documentation from Esri. These resources provide in-depth insights into how ArcGIS can enhance your work, offering best practices, product updates, technical tutorials, and other valuable information for using ArcGIS products. Additionally, you can also explore, again, livingatlas.com to access publicly available and authoritative world data sets. And for content specific to New Zealand, visit the Content Hub site. We have some upcoming training opportunities, including instructor-assisted learning labs on topics such as ArcGIS Online Essential Workflows and mapping and visualizing data in ArcGIS. For more information on these and other training courses, please visit eagle.co.nz/learn. We also have several upcoming webinars this year. On the June 13, we'll be covering the new Local Maps 3.1, followed by webinars on ArcGIS in emergency management and ArcGIS Hub next month. Be sure to register if you are interested. And that brings us to the Q&A session. We have a few minutes to answer any questions you might have. Please use the Q&A button at the top to submit your questions.
Yes, we already had a few questions in, so we can go ahead and answer those. So the first one is, do you have an estimated release date for contour lines for production use? Because last I checked, it was still in beta. Yeah, and that is correct. It is still in beta. So we're aiming to have this officially released out of beta around NZEUC time. However, that is our aim, as in can't promise anything yet, but that is what we're aiming at. So that is a September timeframe, September-October timeframe. There's another question on the shaking layers. I'll probably have to won't be able to 100% answer this. Maybe someone from the GNS team is on the call as well. Otherwise, we can look into it. But the question is if this shaking layers is replacing the last 50 quakes WFS from GeoNet, or if they're two different things. So what I know about this layer. About these layers is actually a set of layers that shows the last 30 days of earthquakes, but also their intensity. So there's a couple of layers in LivingAtlas that you can find, and maybe I can use the button here to put a link into the GNS website where they talk a little bit more about it. But if you need to know more, then we're happy to look into it for yourself, or you can connect to GNS. See if there's any other questions. So there's also one that came in that was a question about LivingAtlas. So if people are nominating, if I'm nominating an item, will Eagle or Esri then manage that item? No, that's not the case. So basically, you can see LivingAtlas as a catalog. So it just references items, so the items will remain your items. So if you want to make a change to the data or the item details, you can do that. The only thing that we you want to ask is if you're about to deprecate an item, is that you follow a deprecation plan for that. And we've outlined that in the story map about nominating a layer, and that is more so to everybody who is using that layer to just give them a bit of a heads up that this a layer is going to be deprecated, and maybe there's a replacement layer for it. So that's the only thing. But if you want, you can pull it out of LivingAtlas at any time. Right, there's another one. I'll probably pass that one over to Mia, and that is the difference. And we get a question more often, I think. I say, what is the difference between data pipelines and things like data interop or FME? So Mia, do you want to take that?
Yeah. So they're both pretty different. I mean, they are similarly, they're both ETL tools. So they extract, transform, and load data from one source into another. FME interoperability has a lot more tools and can read from a lot more formats. However, data pipelines is a SaaS solution, so you don't have to deploy any infrastructure to use it. So although they are sort of similar, it does depend on your use case and what is going to be more useful to you.
Yeah, and one of the biggest differences is that the ArcGIS data interoperability tool is a bit of a tongue twister, whereas data pipelines is much easier to say. Right, another one, and that is about the imagery in S3. So maybe Josh, you want to take that one. So the question is, if you can, you talked about ArcGIS Pro, if you can also publish it to ArcGIS Online. Because you talked about Enterprise and ArcGIS Pro, but is ArcGIS Online an option as well?
Yeah, so you can use it for online, but you'll have to download the imagery from S3 and then upload it, and then it'll be stored in ArcGIS Online. But whereas with the Enterprise, through the workflows we showed with that, the image service will still host the imagery connecting from S3, from the S3 bucket. So you get a bit more functionality with Enterprise. So if you're using ArcGIS Online, it will be best to cache the imagery for a base map and then publish that as a tile package to ArcGIS Online.
Yeah. Thank you. Yeah, so basically that is because ArcGIS Online manages everything, infrastructure and data, so it can't connect to data that's sitting in the cloud. It needs to ingest it. So it is an option, but the base map is a really good one because that is where we see most of the use cases, I think, as in maybe you want to publish some of the historic imagery as a base map layer to your users internally or maybe to the public, and then you can. It's probably useful to create it as a base map and then add it to your maps and apps. I don't see any more questions. So in that case, I'll pass it back to you, Carol, to close it off.
Thanks, Badwin. Thank you all for attending today's webinar. We appreciate your participation, your questions, and we look forward to seeing you at our future events. Have a great day.